In our last video number 25, we have done analysis of variance for 4 groups. Now we are going to use the same commands: importing Tinker as TK, import Pandas as PD, import Math, import Seaborn as SNS, import NumPy as NP, import Matplot. This we don't need it, but I've just kept it. In case we want to add some chart or add something, we can use it. Now here import statsmodel.api as SM. Now from this stat model, we are to add one more line so that we may create OLS. Because if we want ANOVA table, this exercise is for ANOVA table. If we want ANOVA table, then we have to import OLS, ordinary least square, because ANOVA table will give us the variances between the groups, variances within the groups, and then we will be able to create the ANOVA table. So we need OLS. Secondly, we need to create the categories. See, in this case, simply we told the system that we have got the samples, 3 samples, please work on this. They worked. But if we want to show the ANOVA table, we will have to write down 3 more lines. So I'm just copying it. I'm going to start a new file, new Python file, and I'm just going to copy all these commands again. I'm just going to copy. I can work on this also, but I'll make a separate file. Here the separate file has been copied, paste, and I am going to name it ANOVA table. ANOVA table, so that this becomes a separate exercise. Now here I am going to write one line which is importing OLS from the stats model. I'm going to write it. So I have written from statsmodel.formula.api import OLS. This OLS will help us to create the ANOVA table, because it is going to be a kind of linear regression on the categories. Linear regression on the categories. Now here, now we don't need sample. We don't need sample. We are going to write here 2 lines just to create that ANOVA table. Now, this samples we will have to convert into data frame. So df1 is pd.DataFrame sample. Now at the same time I am going to transpose that. For instance, now earlier I showed you the sample. If I show the sample, that will come in the form of, say, I don't transpose. So it will be, let me show you that all these commands, I don't want to work on this. Let me write it hash on each line, and I don't want this. And I will simply write it here df1. Let us say what df1 comes, how it is shown on the screen. Let us run it. It has taken some time to load all the functional packages. Now our Win file has opened. I'm going to select test done. It is going to ask me as what are the numbers, which columns I wanted for my working. 2, 3, 4, 5. So these are my this. So now this one is there. Already the statistics p-value that already ANOVA has been done. There is some difference among the columns, but now this has been shown here as class A. Till our it is starting from 0 to 29, though there are 30 numbers, so it is 0 to 29, but they are shown, the samples have been shown in the form of rows. For our working, we want that it should be in the form of columns as we have seen it in the Excel file. So that is why I am going to transpose. To transpose, just write dot capital T. Let us run it. Test 10. Two, 3, 4, 5. Now these are my columns which I wanted. Now this happened, they have been transposed. Now they are in the form of in the columns. Now we want these column heads called class test A, class test B, class test C, class test D as categories. So they will become categories. So how to make them category? I'm just going to create another array columns df1 columns. So it will be stored in the calls, this class A, class test B, class test C, class test D. They will be stored in calls. I can print the calls, otherwise it is not required. I can print the calls. If you want, you can print the calls. Let us see, let us print the calls. Now we don't need def1, we will just simply say print the calls. Test 10. 2, 3, 4, 5. Now these are the columns, class test A. These are the columns, class test A, class test B, class test C, class A. Now these will be used as category. So what we need it, we want that all the database, the data file which we have created df1, that should be arranged in one column. That should be arranged in one column. And with that, another variable that 1, 2, 3, 4, that is category wise, each column should be categorized as one. So we are going to write down here as df2 pd.melt. This is a new command for you. pd.melt df1 reset index. Now index will be reset and id variable will be the index, and it will take up the value variables as calls. These columns will be taken as value variables. And we can rename the columns as df2 columns, df2 columns index, category, value. Let us see now. I want to show how this looks df2. Just run it. Test 10. 2, 3, 4, 5. So now all the numbers, they have been put into one value, has been put into one column, and categories have come. So we have got now the main two columns, a category and values, and this is the new index which is coming up from this one 0 to 119. Total entries are 120, so it is starting from 0. This is the new index. So we are interested now in values and category. So values will be regressed on categories and you will get it a model. Model is equal to OLS value tilde category, that values will regress it on category. Data is our df2, which will fit a line, and then it will create an ANOVA table, and we can show the ANOVA table. Let us run it. We don't want to show now df2, we have already seen it. This was our for our purpose. So run test 10, 2, 3, 4, 5. So it has now, first it has, this one is our test statistics, but we have shown it print columns, so that's why it is printing the columns. We are printing the columns. So we actually, there is no need to print these columns now. We have that just for, I have already shown you. And now this is your ANOVA table. And you can write it here as print ANOVA table. Print. So we can write it ANOVA table within inverted commas, and also write under this /n, and that will give you that ANOVA table in the next line. So let us run it. Test 10. So we have got this ANOVA table, sum of squares, categorize wise between the categories, that is between the groups. So we can also write it here categories, instead of categories we can write down the group. So 2782.5, degree of freedom is 3, because there are four groups, 4 categories. So we lose 1 degree of freedom. So that will give us 3. And then F is coming as 8.1557. This we have already calculated here. F is 8.156, and then 0.000057, which is up to 3 decimal, it is 0.00. It means it is less than 0.01, which means this F, this all variances which are there, the alternate hypothesis which we have selected is statistically significant at 1% level. Thanks for watching. In the next video, we are going to see the differences in A and B, B and C, C and D, and D and A, and then we will see which one is having higher difference and lower difference, and whether those differences are statistically significant or not. You can manually calculate, or you can also calculate as we have done it in video number 22. That is, you can compare A and B, then A and C, A and D, B and C, C and D, A and A. But this, you need not do it multiple times. You can simply do it in with one command. That we will do in the next video. Thanks.